we got the graph, and he's reiterating the fact that at each of these points, the derivative is going to be different. It's related to what we've already done in a sense. If we want to estimate the derivative at negative 2, what I would do, just estimating at a negative 2, 1, 2, that would be at this point here, I probably would try to use a ruler would be the best thing to do. But if I'm just making this small line, all you have to do is estimate rise over run. And you don't have to be perfect. So if I use this point and decide to use that point, because it looks like that's where I crossed the intersection, I could probably say 1, 2, 1, 2. What would you say that slope estimates to be of that line? No, not 1. Wouldn't it be a negative 1? Aha, you got to pay attention to that. And then let's do the negative 6 one. Let's do a couple of these. Negative 6 would put me at 1, 2, 3, 4, 5. This point right here. So I'll try to be accurate enough to draw a tangent line.
So
yes?
For the first one, was it for the negative 2?
It well, yes, for the estimate, my estimate. So I'm going to use this one, and probably that point looks very good to me. So obviously that's going to be positive. 1, 2, 3, 4, 1, 2. 4 over 2, positive. That looks like a what? A 2. 4 over 2 would be 2. I'm just estimating it. I could be wrong, and you may have a different estimate depending on, if you use a straight edge and you actually find very good points, you'll be more accurate than me. All right, let's do another one, negative 4. Negative 4 looks like he's at 1, 2, 3, 4. Oh, okay, this one should be piece of cake. Or as they say at home, papitas. What does that look like?
0.
Yeah, that's a pretty good estimate. I'm not even going to be surprised if it's exactly 0. So then what we want to talk about is the function increasing, decreasing, or at a relative max or relative minimum. So go back and look at it, negative 1. At the negative 1, oh wait, did I do a negative 1?
You put it for negative 7.
Oh, I did a negative 2, didn't I? Is that even on the chart? Okay, so I did that. Wait a heck. Okay, let me change those numbers up. Negative 2 was the negative 1. Why did it look different than what I was looking at? What did I do for the next one? Was I at negative 6?
Yeah.
Oh, that one's okay then. I didn't do negative 7 then, right?
No.
So we'll go and do that one while we're here. 1, 2, 3, 4, 5, 6, 7. It's down here. So it's going to look like, this is going to be a little harder because it doesn't look like anything's nearby. All right, what other point could I grab besides this point here? Right down here. See how it crossed the intersection? So my estimate would be 1, 2, 3, 4, 1, 2. Wait, that also looks like a positive 2. Yes. Yes. Positive 2. So I'll go up here and put positive 2. So that is strange that negative 6 also was a positive 2 as well. Could you have 2 different places where the slope was the same? Yeah, you have a lot of them, a lot of repeats. So anyway, let's look at the ones we've done. At the negative 7, I'm going to zoom in on it. It's this one here. Does it look like the function is increasing, decreasing, or is it at a relative max or a relative min? What's it look like it's doing there? Matter of fact, I could say this. It's the same as it is here. 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 What's all those places have in common? It's what? Decreasing? From left to right, I'm going down? Increasing. The slope of every one of these places would be a positive slope. So we would say it is definitely increasing. Let's do the -6. Well, I already gave you that answer. -6, that was 1, 2, 3, 4, 5, 6. That's also increasing, right? Because it's a positive slope. You can look at the slope. If the slope was positive in both places, then it's increasing at both. What's happening at a -4 when 1, 2, 3, 4, okay, when that slope was 0?
Or relative maximum?
It's a relative max because it's on top of a mountain. Okay, so we would write out relative max, a maximum, and at -2, the slope's negative. So if I look at it, look at -2. Look at -2. The slope is negative. So therefore, from left to right, the function is falling, isn't it? The function is falling until I get to this place. It keeps falling, so we say it's decreasing. Decreasing. And do I want to do a -1, or did I do enough of those? I think I've done enough of those. I'd like to do maybe at 1. Is 1 on our list? 1's on the list. What's happening at 1, real quick, guys? What's happening here at x is 1? What does it look like? 0, isn't it? Horizontal line. So that looks like it's approximately a 0. Is it increasing, decreasing, relative max, or relative min? That one's a relative min. When we say relative, it means that if you draw a circle around the area, nothing near that x value is lower than that actual point. Nothing is lower near this point. So that's why it's called relative, because you can say, well, there's other places. This place is lower. This place is lower, but it's not near it. It's far away, a whole other continent for all that matter. Now he wants an equation of the tangent line at this x. So since we're just guessing, we need to figure out what ordered pair did I have. -7 would be what would be the y value of -7? 1, 2, 3, 4, 5, 6, 7. It was this one right here, wasn't it? Is it down to -3 or -4? What is it? Someone has to tell me.
-4.
It was a -4? Does it match up on your paper? So I got to put -7, -4. And so we said that the slope was approximately a 2, right? So I wrote that out because the formula I'm going to use is y minus y1 equals that slope times x minus x1. I'm just going to plug in my values and then run away and leave it. Y minus -4 is +4 equals the 2 times x minus -7, so x plus 7. And I'm going to run away and leave it there. I'm not going to do any more work. I'm not going to simplify. I don't need to. So when I do the next one at -6, I got to find the -6. 1, 2, 3, 4, 5, 6. Where does the y value look like to you on your paper? Somebody? It looks like a 0. So I'm going to put the ordered pair to be -6, 0, and that slope also was about a 2. Yep. So y minus y1 gives me y minus the 0 equals that 2 times x minus -6 gives me +6. Most people would not even write the y minus 0. They would just write y equals a 2 times x plus 6. And that's fine. They're both good answers. If you say that 0, I wouldn't care. All right, now we're going to do, if the slope is 0, horizontal line, don't work too hard. The answer must be just y equals to a number. So what's the y value when x was a -4? The y value looks like a, how high is it? Some of you are just not paying attention. 2. So it's always y equals to 2. I mean, you want to use the point slope form? If you want to see what happens, in case you forget what I just said, look what it looks like. Y minus the 2 equals to the 0 times x minus 4, x plus 4. Do you see what happens? What's 0 times anything? This is really y minus 2 equals to 0. Of course, y equals to 2. You see? So you could use the point slope form. It's still going to give you the same answer, y equals to 2. I suppose if you left it written out like that, the AP test would still have to give you full credit. Because the rules of the AP is you never have to simplify. You never have to reduce fractions. You never have to move equations in different places and rewrite them. Whatever answer you have is the right answer no matter what form you leave it. So you technically could have just wrote this out the way it is and left it. I mean, I would hope that you would know what's y equals to 2, but not everybody's going to see it. And so I'm not going to throw a stone at you. All right, now at -2, the ordered pair at -2, what does it look like to you? Ordered pair at -2. 1, 2, how high am I going? 1, yeah, thank you so much for helping. 1. And the slope, I said, in my opinion, was approximately a -1. So y minus the 1 equals to the -1 times x minus -2, x plus 2. And I'm going to leave it. Could I simplify it easily and solve it for y? Sure I could. I don't have to. So why do it? On the AP test, that can make a difference of you getting a point or no point. Because you're only human. We all make mistakes when we rewrite things. It happens to us all. Last one that I had done at a -1. Let's see, at -1. Was it -1? Yeah, -1. Let's see, -1. Wait, I thought I did a 1. I didn't do a -1, did I? I guess I did. What was the slope at -1? 1, 2, 3, 1, 2, 3. I guess I did do it. The slope at a negative. You know what I thought I was doing? I thought I was doing the 0. This one I didn't do. If you copied me, I'm sorry. I wrote it in the wrong line. That's the one I did, and we said it was a relative minimum, wasn't it?
Yes.
Yeah, okay. So the ordered pair at the 1 is a -1, 2, 3, 4. I think it's 1, -4. So 1, -4, and the slope was 0. Do you have the answer really fast in your head without having to do the work? When the slope was 0? So close. Y equals -4. Yeah, exactly. That's what it is. Yeah. So you get the point of increasing and decreasing, and absolute max and absolute min, and finding the equations at those places. Of course, we were just estimating everything. As I look at that one here, using only words of a derivative, what could you tell me about why that's a relative max? Just what would you say if you could only describe it in terms of derivatives? Step out on faith. I got to give you another hint? Tell me what the derivative is before I get to x equals to 1, 2, 3, 4. What's happening before I get to x equals to 4? What was the derivative doing? -4, sorry. What was the graph doing? It was increasing, right? What happened on the other side of -4? Oh, so you could say that it's a relative max since f of x changed from increasing to decreasing at x equals -4. That's a perfect explanation that it's a relative max. How do you know it's a relative max? The function was increasing, now it's decreasing. Was increasing, now it's decreasing. And the only thing that could have happened in there was where it changed directions by a relative max. What could I say over here about at x equals to 1? How do I know it's decreasing? At x equals to 1, f of x changed from, I'll do it in different words. Instead of I said increasing to decreasing, I'll say f prime of x changed from, let's see, it was -0, positive. It changed from f prime of x to be less than 0 to f prime of x to be greater than 0. Here are two different ways. Here I said from increasing to decreasing. Here I said the derivative was less than 0, now it's greater than 0. It was less than 0, now greater than 0, minimum. So I didn't finish that up, did I? F of x has a relative minimum at x equals to 1. There, let me add that to it. So those are called justifications. You know, when they make you write those paragraphs of why, it's all about the derivative, guys. What's happening with the derivative? What's happening with a function? When you say the function was increasing and now it's decreasing, that's good too. Because increasing meant the positive derivative. Went to negative derivative. That meant the function started to decrease. So there's two game plans you have when those questions are asked. Based on what you observed in the table in the previous page, what inferences can you make about the value of the derivative and the behavior of the graph? I guess what stood out in my point of view, I stood out as f of x is decreasing when f prime of x is less than 0. I also noticed that f of x is increasing when f prime of x was greater than 0. I also noticed that f of x has a relative max or min when f prime of x is 0. Does that make sense? And the reason I wrote these three things, they're worth a lot of points. So often they're going to ask you for the behavior of the graph. And you're going to find these special x values, and you're going to say, what's happening at x is 2? And you're going to say, when x equals to 2, f prime of x is less than 0, therefore the graph is decreasing at x equals to 2. At x equals to 5, the graph is f of x, or the graph, usually you should say the function, is increasing because f prime of x was greater than 0. These things here are worth so much justification. When they say, what is happening at x is 2, and you say it's increasing, they're never going to say that. They're going to say, what is happening at x is 2, and justify your reasoning. These are your 3 justifications that work all the time. Just describe what's happening to the derivative. Now, the one about max or min, I named them both. But let's go back and look at the picture for a minute. Now he has a table of values. This is no different than the points on the graph, but we have to look at. We only know what's happening, but at these ordered pairs. We don't know what's happening at x equals to a negative 2. I can only guess, based on the behavior of the 2 endpoints before and after negative 2. So numerically, the value of the derivative at a point can be estimated by finding the slope of the secant line. So if I want to find out what the slope was at x equals to negative 2, I would go and use this segment here.
Good afternoon, students
We'll
and staff.
finish this up
A few announcements to end our day today.
next time.